Welcome. In this lecture, I want to introduce relations in really a step towards equivalence relations. Though relations on their own are very important. You would have seen them, for example, with less than or less than or equal to, or the containment of sets, or things like this. In fact, those are order relations. But uh, they're important also for equivalence relations, which are one of these things that show up absolutely everywhere. And they're kind of a special kind of like subset of Cartesian products, is the way I'm going to introduce them. There are other ways to introduce them, but I like this way, so it's the way I'll introduce them. So recall. So the Cartesian product of a set with itself, so the Cartesian product of a set A with itself, we're going to do this way. So we're going to do A with itself. And even though it's the same A, we're going to go ahead and give this different notation for the different copies of A. So we'll give the first copy the orange and the second copy green. Okay. And this gives all ordered pairs of elements of A. Okay. So this gives all ordered pairs of elements of A, right? So pairs of, and then the elements are in A. So we'll write that with, right? So elements of A. Okay. So if I'm looking at a Cartesian product with itself, then even though the order matters, like 1, 3 is not the same thing as 3, 1, both 1 and 3 had to come from the same set. Okay, so we're just looking at pairs of elements of A where I've decided which one is first and which one is second, right? So that was Cartesian products. Now, by focusing, so then new, which is what we're going to be talking about, is that by focusing on, so by focusing on only some ordered pairs, on only some ordered pairs, we can understand how elements of A relate, okay? So we can understand how, I know it's the same thing as I wrote right there, but I'm going to put it like this so that it's it doesn't get too smushed together. So elements of A relate. Okay, so as I said, they're just going to focus on some of the pairs. Only some pairs are going to be included, but they are going to be pairs, and the order is going to matter. So let's look at an example. Okay, so these are going to be some examples where in this circumstance, we're going to let A equal the set. So let A equal the set 1, 2, and 3. So just those three numbers, 1, 2, and 3. Okay, so we can capture, all info about this less than symbol on A. Let's just do it right. Okay, so on A, right? i.e., so what is this information, right? What is less than, what is the information of less than in here? Well, and I'm going to suggestively color these. What do we know? We know that 1 is less than 2. Oops. Oh, well, I could have done that. Okay. 1 is less than 2, right? I know that, what is the other information? I know that 2 is less than 3. And I know that 1 is less than 3. And that should be all the information. Okay, that's all the information. So how am I going to capture that? I'm going to capture that via the set. So here's the set. Okay. The set is just going to contain, very suggestively here, watch this, it's right underneath here, so it's so clear where how these correspond. Okay, so the first ones are 1, 2, 1, and yes, I'm just looking right up there, and 2, 3, 3. Okay, so what's happening here, just kind of looking at this, the fact that 1 is less than 2 is going to tell me to include the ordered element 1, 2, the ordered pair. The fact that 2 is less than 3 is going to tell me to include the ordered pair from the Cartesian product, 2, 3. The fact that 1 is less than 3 is going to tell me to include the ordered pair 1, 3 from the Cartesian product. It's going to end up in the relation also. So we observe that this is a subset of, so this is sum of the elements of A cross A. Not all of them, right? But the ones that I chose told me I'm talking about less than. Okay, the same information as saying what less than means. I would get exactly the same thing. Okay, so let's look at another example. What about if we want to go the opposite direction? So 2. Okay, for now we want to go for greater than on A. Right. What should my set be now? Well, now I just want to swap all these. Right, still contained in A cross A. Okay, so now I want to put, let's see if I can do this without making any mistakes. I'm doing it quietly so I don't make any mistakes. I'm very focused. Okay, so what is the information that each of these gives me? Right, like up here, this one is giving me the information that 2 is greater than 1, right? Whereas before, when it was swapped the other way, see, this is really showing that order matters. When it was swapped the other way, it was giving me the information that 1 was less than 2. Now it's giving me the information that 2 is less than 1. This one is giving me the information that 3 is greater than 2. This one is giving me the information that 3 is greater than 1. Okay. And so that's all the information I need to know what it means to be greater than on that set. You know, I need more information if the set is bigger. Let's look at one more. So we're going to look at equality. So here, so for equality, right, what does my set look like now? Okay, well, we precisely get that everything is equal to itself, but to nothing else. So I just get the pairs 1, 1, 2, 2, 3, 3. Okay, so just by telling you which elements are in the set, I'm telling you the information of what it means to be equal on that set, or what it means to be less than, or what it means to be greater than. And I will, so here's kind of our cautionary remark that I do in another color that you can't tell is another color, but once again, it just makes me happy. Okay, so my cautionary remark is that order matters. Right. Including right, so if I include 1, 3, versus 3, 1, I'm describing a different relation, right? I'm describing, describes a different relation. Right. For example, the first one could be describing, right? We could be doing less than versus greater than. Okay. So, picking out certain pairs of elements from the Cartesian product tells me information about what I want to be related to what, such as this lesson. I want to know that 1 is less than 2, okay? And 1 is less than 3, and so on. But and then I'll give the formal definition, and then this kind of idea is important in equivalence relations, okay? So that made some sense and was helpful, and I will see you in the next lecture.